container problem. The problem starts with that you get in a list of numbers. This list of number is represent a point on coordination. While you want to find two lines that together the xy form a container. So what is the meaning of that? The meaning they want rectangles, but out of that, because if we look on the problem here, so you get 1 5 4 3. So 1 1 5 1 5 2 4 3 3 3 4. So you get in we take in when we are taking 5 and 3, it's like we had bars. So this is a bar in height 1, in bar in height 5, bar in height 4, bar in height 3. So if we took it and we'll create a bar out of it, so we can create a triangle. This was here a bar in height 5, here in bar in height 3. So we go from 3, which is the minimum, all the way to 5, and then we go like this. This is the rectangle. So they take in the distance, two numbers apart, and the minimum of the 5 and 3, which is 3. 3 double 2 is 6. So this is part of the solution already, because if we look in on that, we can do the first thing we can do is go like this. We can always scan from the right, but from the left all the way to the right, and each time calculate how much um, container area we get. So how do we collect it? We take the I, which is the left, and the J, which is the right, and we move in it every time one step, enlarging the the rectangle. Another way, which is smarter, which is much faster, is to understand that we want to find the maximum, which is the hint in here. So using that hint, what we will do, we will scan from the left to the right. How we do that? We say in left, right, and we moving them one to the other. So if you will notice, we didn't add any stopping inside. The stop is here when they collide. This is I already found the maximum. Why I take that? Because I'm saying whenever I am on the right, on the left, I get the maximum distance between the two. If this was a 5 and here it was 5, then that was the maximum. I could create a very large rectangle. This is not the case. I am doing here and then I move in that one. So 3 is bigger than 1, then 1 is the one that limit me. So I'm moving it 1 to the right, the I. Then I go like 5 and 3. Okay, 5 and 3. So 3 now is the minimum. So I got two distance, 3, 6. Okay, 3 now limit me. So I'm moving the 3 one step left. So now it's 4 and 5, but now the distance is 1 only. 1 double 4, which is the minimum, give me a size of container of 4, and one of them is moving aside, the 4 in that case. They're hitting the same point. Boom, we ended. Instead of 1, instead of n double log n steps, we minimize it to n sizes, n steps to find the answer. So let's move on the answer again. We start in it. I'm collecting every time a new temporal variable just to be easier. Collecting if I found the new maximum container size, if the right side is the limiting factor, then moving it to the other side. Okay, that was it.